So we have generated our dataset data, and now we want to calculate the mean for each sample that we have. So I'm going to create a new dataset which I call data mean. So it's a dataset which contains means, which contains averages. We're going to use NumPy, and from NumPy the function mean. So we use this variable data, which has 10,000 rows and 10 columns. So the way we think about this is these are samples of 10 observations, and we repeat this process of sampling 10 observations 10,000 times. So the distribution of m comes from the 10,000. So that means that I want to take the average here over the 10 observations. So I want to take the average over the columns, not over the rows. So I need to specify the axis here, and the axis is 1. Yeah, because remember, in Python we start counting at 0, so the first dimension, the 10,000, is axis 0, and the second dimension, the 10, is axis equal to 1. So just to be sure, if I look at data mean, I want to know what the shape is, and I have 10,000 observations in data mean, which is correct because I've taken the average over the 10 column observations. So all the columns are reduced to 1, only containing the average of these two, so I'm left with 10,000 rows. And for these 10,000 rows, I can actually plot the distribution. So I'm going to make a histogram of my new dataset data mean. I'm going to specify density equal to true. I don't want the absolute numbers, but I want the density. So let's first make a very simple plot, and then we're going to make it a bit more sophisticated. So here we have our first plot. So you can see that we have observations which are between 0 and 1, because we're drawing from a uniform distribution between 0 and 1. You can already see that the average is around 0.5. So it means that the average of the sample averages is close to 0.5, and you can already see the famous bell-shaped curve, which should give you an idea of the statistical process which is actually generating this outcome. So to make it a bit clearer, I can increase the number of bins. Let's say we want to have 50 bins. So here you see already better that we're moving to a normal distribution. So now I can add some things. So I can say, let's add a title. So this is the distribution of the sample mean, which we denoted by m, and I'm using the dollar signs here because I want this in LaTeX. So I can also include an X label, which I also do in LaTeX if I want. So again, the dollar signs. And we can have a label on the y-axis as well. And here this is just normal text. Oops. So, sorry. This is frequency. Yes, now I have this title, distribution of sample mean. I have the m for the mean on the horizontal axis, and I have the label frequency on the vertical axis.